Yeah. It's the only one I have this semester. And I'm pulling this straight from the book, but you don't have the book, so you might need to copy it. You're gonna, when you see this, you're gonna go, oh my gosh, this is so easy. Yeah. So this is a good discussion on minimum wage. I wish I just had, I can't find my document camera. That's what I need. So you can copy it so I don't have to write it. Yeah.
That was minimum wage.
That was minimum wage. I know. Well, so there's the purchasing power in $1996. So this is minimum wage in 1955. Actually, never mind. It's from 55 to 2005. But because this is an old book, they converted it over to what that would be in the year 1996. So 75 cents an hour in 55 was like $4.39 in 1996. So I'll give you all a second to copy that, because then we're going, this is what this section is about, taking sets of data, taking things like that and using it to analyze and answer some questions, and then taking some word problem type things and using that information to create some equations. This is a very, very, very easy section. We'll come up with, this is what we call a numerical model. I forgot y'all's candy if you won yesterday. I'm sorry. There's some donuts back there, though. Hmm. Well, I mean, they're school donuts. Ah, bless you. Use the numbers to analyze trends, to look at things, to see what is happening with the data. So looking at this, in what 5-year period did the actual minimum wage increase the most? So what am I looking at? The biggest jump, right? The biggest jump between periods. Where do you see that? It looks like 25 cent, 25 cent. So you're saying from what? 75 to 80? It's a whole dollar. So between 75 and 80 was the biggest increase in minimum wage. Let's see, and that's a dollar. Okay, all you U.S. history people, what could have happened during that time that caused such a jump in minimum wage? What was going on? What was it? Was it the Gulf War? Oh my gosh. Was it? Oh, I gotcha.
She's not crazy.
Yes, she is. I'm sure she is. Yeah. How about, even though that was the biggest jump, oh my goodness.
Any student who does not have a laptop should report to the library. That is any student on campus that does not have a laptop. Please report to the library at this time. Thank you.
When was it the best time to work for minimum wage? And tell me why. Okay, on this chart, from between 55 and 2005, when would it have been most advantageous? Why? It had the most purchasing power. That was like earning $6.47 in 1996. So that chart there, do you see how it's disseminating that information and giving it to you so that you can see and compare how it compares to that $1996? It puts it all on a level playing field for you. If a worker on minimum wage in 1980 was earning nearly twice as much as a worker on minimum wage in 1970, and yet there was a great pressure to raise minimum wage again, why would that be? Okay, so in 1980, they were earning almost twice as much as 1970, right? Look at 80 compared to 70. But in 1980, they were really, really, really wanting to raise the minimum wage again. Why? It still wasn't worth as much. It's kind of like where we are now. I would be willing to bet. Right. And that's the problem we're in right now, is because inflation, you're exactly right. Yeah. I told y'all this was going to be silly easy, right? Because we're just analyzing numbers and tables and data and things like that. We'll do some graphing of some things and see if we can find some trends and that kind of thing also. Let's look at another set of data. If you don't want to write these down, you don't have to. I should have told you that before, huh? I'm sorry. That's all we're doing. We're just looking and analyzing trends and things like that and looking at it right now. Usually that. You don't, yeah. We looked at it. We did. We said, when did it increase the most? We said, when was it the best time to work for minimum wage? And then why in 1980 was there pressure to raise the minimum wage as opposed to 1970? And it's because the purchasing power actually went down instead of. So that's kind of like if you convert, kind of like in 1920, if you had a quarter, that would be the equivalent of like what, I don't know, $10 now or whatever it is. So it's converting everything over to a common year so you can compare it then. All right, look at this table. U.S. prison population in thousands from 1980 to 2005. So this shows the growth in the number of prisoners that were incarcerated in state and federal prisons at the year's end for selected years between 80 and 2005. Is the proportion of female prisoners increasing or decreasing over the years? All right. Is the number of female prisoners the proportion of the number? How do you know? The number of females are definitely increasing, right? But is the proportion to the total number increasing or decreasing? Because even though the females are increasing, look at the males, they're also increasing, right? So are they increasing? If you look at the proportion of them, is the proportion the same? It's 13 out of 329, and then you got 23 out of 502. Is the proportion increasing or is it decreasing?
Increasing.
Increasing. Did you just guess?
The number's getting bigger.
It is getting bigger. So if you were to do 13 divided by 329, right? Do you see what I'm looking at? 13 divided by 329. And then I go on. Where my little pen? And then I did 23 divided by 502, and then I did 44 divided by 7. So I see what proportion there was there. It is increasing, actually. Uh-oh. Does that make sense to everybody? These are numeric models. If y'all got that, I'm going to stop and I'm going to go into algebraic models. Y'all okay? All right. Let's talk about an algebraic model then. You want to do another one? We're just saying that.
Wait, so what? Why are we?
I don't have another one. We already did that one. Oh my gosh. Let's talk about algebraic models. What's an algebraic model? That was a numeric model. What's an algebraic model? It was a numeric model. So what's an algebraic model? I hear numbers. What does algebra do? What did you learn to start doing in algebra? Variables, right? I'm coming up with an equation with variables. That's an algebraic model. So let's think about this for just a second. Y'all are probably too young to remember, but I'm pretty sure Little Caesars, whenever they first came out, were square pizzas or rectangle pizzas. So that's disgusting. It definitely still tastes the same. Okay, so let's say Little Caesars has a rectangle pizza that is 18 inches by 24 inches. But yet they charge the same price as Pizza Hut's 24-inch round pizza. Who gives you the best value for your money? I know. Okay, so you're absolutely right. We need to take the area of the pizza into account. So here's where we're going to use an algebraic model. How do you find the area of a rectangle? How do you find the area of a circle?
Half of the base times the height.
How do you find the area of a pi times something? Thank you. Thank you. If you said it and I couldn't hear you, I'm sorry. So let's use these algebraic models to find out which one would give us the better money, the better value for our money. So how much area of pizza are you getting in a rectangular pizza? Is that what it is? 432 square inches. How much pizza are you getting on the round? Now I said 24-inch round. Is 24 the radius? It's half of that because that's the diameter. So here I'm going to have 12 squared times pi, 144 pi. I need to do that on the calculator to see if that's more. 452. Which pizza should you get that would give you the most value for your money? That's right. The round one. The round one. The last type of modeling that we're going to talk about is a graphical model, everybody's favorite. Well, we're going to take a numeric model and convert it over to a graphical model. And then I'll do a couple examples like you'll have to do in your homework so you can see what we're talking about. What classwork? All right, graphical models. I hope this is like stupid easy for y'all today. Because it's going to get harder. So let's say I gave you do y'all have your calculators with you? No. Do enough of you have it with you that I could show you how to do it on the calculator instead of by hand? Yeah. Yeah. I've heard of it, but I'm not sure. Why don't you look at this set of data here? There you go. What I want to do is I want to know if this follows any type of pattern. If maybe it looks linear or like a quadratic or like a cubic or anything else. So I'm going to show you how to put this on your calculator. So if you take your calculator and you hit stat, did we do this at all in Algebra 2? I used to do it in Algebra 2, but we may not have that tonight. Stat and over to edit. You should have something that looks like this when you get there. Stat is the button that is 2 over from alpha. Go to alpha and go to the right. You'll see stat. You can clear them out. So if you have numbers in there, go up to the top, hit clear and enter, and it should clear the whole list. Okay? We're going to type in list 1, we're going to type in all the x values, and in list 2, we're going to type in all the y values. And then I'm going to show you how it'll graph it for you, okay? And we can look. What are you looking at? What are you looking at? All right, so in this x part, I'm going to enter 0, 5, 10, 15, 20, and 25. 0, 5, 10, 15, 20, and 25. List 2 is going to be my y values. And I'm going to need to look at them because I don't remember. So I'm going over to list 2 here. And I'm going to do 3.9, 4.6, 7, 6, 6.7, and 7. So your list should look like this. 5.7, 6, and then 6.7. Everybody got there? I want you to go into your y equals, and oh my gosh, make sure there's nothing entered here. Somebody has clearly entered a bunch of stuff in this one. Make sure, hit y equals, make sure everything's cleared out for you. Yours says x equals. All right, now what I want you to do is hit second y equals, which is stat plot. It's really cool. I hope you appreciate this because it is cool. Hit enter, and I want to turn it on. So I'm going to hit enter on. Okay. I'm going to go down. I could make this into all these different graphs. I'm going to keep it as a dot plot here like that, but I could make into any type of statistic graph there. If you do problem stats next year, you'll get into a lot of that. And make sure make sure it says X list, list 1, Y list, L2. Okay, that's telling it I want my list 1 to be my X's, my list 2 to be my Y's. And if you want to change the way your dots look, that's all Mark does, is it'll just use a box, an X, or a point, whatever you want. So if you've got fancy calculators, you can do even more with it. Now, what I want you to do, once everything, yours looks just like mine, hit zoom. Nine. Zoom 9. So think about all the scatter plots you used to graph in probably Algebra 1, pre-algebra. Lines of best fit, your calculator will do that here as well. But that's what your scatter plot should look like. So this allows us to really look, and it's a more accurate view than if we sat here with a piece of paper and did that, right? Let me, yeah, zoom 9. Now, let me show you what else we can do with this, because this is really cool. If you go into, see the button that says Stat? Right here below Delete. Stat. Go over to Calculate. And do you see, do we all agree that that looked linear? It looked more linear than quadratic or anything else. So I can form, do y'all remember learning about lines of regression? It's a line of best fit is all that is. I have all these different regressions that I can do. If it looked like a line, I could choose 4 for linear regression. If it looked like a quadratic, I could choose 5 for quadratic, cubic, quartic, and so on. So I'm going to say this looks like it follows a linear pattern. So I'm going to choose number 4. And I'm going to hit enter. Okay. Now, here comes the cool part. I didn't do it. If you've got a fancy calculator, when you hit linear regression, you'll have to go down and tell it to calculate. Enter. All right. Here's my A value. Here's my B value. So somebody keep that up off of it. So now I'm going to go into my Y equals. This is the cool part. What was my A value? What? Give it to me again. We'll leave it 0.129. We'll round it. X. And then what was the B value? Okay, we'll stop there. That's close enough. If I graph this, this should represent my data points on there fairly accurately, yes? So now hit graph. And there's my line of best fit. Isn't that cool? It does, because it's, if you're going
to this interruption. At this time, we need any student in grades 10, 11, or 12 who did not attend their class meeting this morning. For example, that would be morning WTC student, to report to the auditorium at this time. That is 10th, 11th, and 12th graders who did not attend the class meeting this morning. Thank you.
Okay. What do you mean? So you don't want your stat graph on there anymore? What you'll have to do, and y'all listen carefully to this because this will throw you sometimes, and some of you had this problem last year, but you didn't, and I just did it for you. See how at the very top here, it's highlighted in black, that plot is? if you just scroll up and hit enter on it and come back down, that turns your stat plot off so that scatter plot's not on there anymore. And then you can just do a regular Zoom 6 and it'll be just a regular graph. Does that make sense? What boxes? Did you turn it off? Okay, I just turned it back on. But if I turn it off, the stat plot, or do second y equals, and here make sure off is highlighted instead of on. Whenever you click play. Okay, now you turned it on. So now if you go back and you turn it off. Go up. I don't know the right answer to tell you because I'm not 100% sure. I don't remember if it definitely didn't count today. Now, let me extend this a little further, because this is what you'll have to do in your homework sum, or your classwork, or whatever you call it. I'm going to put my equation back up here. So this data that we input actually represented, back to the, I don't know why they're so worried about how many women's in jail. The percentage of females in the prison population at years after 1980. So what if I asked you what your prediction was for the number of females in prison in the year 2022, which is now? What would you do? Because we just graphed the scatter plot. We found the line of best fit. We have an equation for that. What would you do now? Say again. So I'm going to think about that line of best fit, which we said 0.129x plus 4.05. My x is my years after 1980, and my y would give me the number of females in prison. So if I want to know in the year 2022, what does x equal for 2022? How many years after 1980 is 2022? 42. Plug that in, and what do you get? If you're still in your calculator, We're going to focus a lot more on calculators here than what we did in Algebra 2. But if you're back on this equation here, right? And remember, I graphed that. That's in my y equals. So now if I hit second graph, which is my table, I can literally, oh, I got to change my table set. I can come in here and just say, okay, if I put 42 in for x, there's my y. And I can use that table to evaluate. Second graph, is it letting you type things into x or no? Do second window, which is table set, and make sure the independent is x, make sure independent is highlighted ask. You know how to do this already, don't you know? Oh, I thought GJ had you right on the calculator. Second graph should take you to the table, which is just a T-chart, basically, for the point. Well, you can type in any value you want for x, and it'll give you the y value. What's it say? All right, everybody okay? Yeah, you're not okay. Where'd I lose you? All right, so you will have a couple that you'll have to do where you will need to input this, find the linear regression equation, and estimate a value out in the future. Does that make sense? Like we just did. All right. I didn't quite anticipate. I realized that on the homework. Now, this book is a little wonky, so let me explain it to you. Do you see how there's a quick review here first? That's not the 1 through 10 I'm talking about. We always start at the exercises unless otherwise indicated, okay? This is all in Canvas there for you. So the first 1 through 10 give you 10 different tables of information, okay? From those 10, then the next thing that you have here are 10 graphs. Then the next 10 things you have are 10 equations. And so your job is to match up the numeric to the graphical to the algebraic model. Okay? Use your calculator to help you. You can graph all of these equations and see which one looks like it. You can, don't make it harder than it is. Okay? All right, so that's 1 through 10. Then you're going to have some sets of data, some tables there that you will be analyzing, and you'll answer the questions that follow as you analyze. Again, all this is on Canvas. We won't start solving until tomorrow, so you won't have any of that. So I think that's about